Hi everybody, it's Mrs. Tellas. We skipped section 9.4, completing the square, and we are going to section 9.5 today. So we're going to be learning how to solve a quadratic equation using the quadratic formula. And this is section 9.5. Okay, so these are all questions hopefully you have some familiarity with. So standard form of a quadratic equation. So y equals x squared, or actually ax squared, plus bx plus c. A lot of times we change that y to a 0, so that we can either factor or solve or do what it is that we're doing. If we have to solve it in any way, we're going to either need to use like quadratic formula or square roots. We usually change that to a 0 if it's a square root kind of thing. Okay, so either of those work for standard form, but really the y is more correct. But we often change the y to a 0. And then what are some ways to solve quadratic equations? Well, today we'll be learning about the quadratic formula. And it's a long one, but it's totally doable. And then what other ways do we have? Well, we learned in 9.3 about taking the square root, either when it's perfect or not perfect, and rounding with a decimal. This has to have no bx to do this. Okay, we learned about graphing, but if you noticed on the review, graphing is probably the most laborious one because sometimes they aren't nice numbers on the x. Sometimes it doesn't cross right at like 3 or 4. I mean, sometimes it crosses at like 2.684 negative. So graphing is not really my go-to usually, actually ever. And then my go-to that I check every single time is factoring. Because hopefully by now you're getting pretty fast at factoring. You can kind of eye it and see. So I will look at it today to see if it's going to factor, but I'm actually not going to factor anything today because I want you to learn how to do the quadratic formula. And then some other names for finding solutions would be roots, zeros, and if you see the word solve, you're going to want to find the solutions or the roots or the zeros, and then the x-intercepts, or just where the parabola crosses the x-axis. Okay, so all of those things mean solve the quadratic, and you can use any of those methods above, whichever makes you happy. Today we're going to be focusing on the quadratic equation, though, so you can learn how to do that. So there's my quadratic equation. Go ahead and press pause and write it down. And then what's underneath the radical sign down here is called the discriminant. So b squared minus 4ac is called the discriminant. And there are some problems in your homework that ask you what the discriminant is and then also what it means. So based on what the discriminant is, you can tell if how many roots it's going to have, whether it will have 2 roots, 1 root, or no roots. So you'll be doing some problems where you're looking for the discriminant as well. And that's just a small portion of the quadratic equation. Okay, so you're going to want to write that down too. Then I have a little video for you. You should watch this video. It's a way to remember the quadratic formula, and it's got a song about Pop Goes the Weasel. So I'll let you watch it. Up to you. Okay, so I have a parabola here. It says if the discriminant is negative, you need that information. So if you're doing the quadratic formula or they're just asking about the discriminant, so b squared minus 4ac, if you plug your a, b, and c in it, a, b, and c in, and it comes out as a negative number, doesn't matter if it's an integer or a decimal, what it is. If it's negative, that means there are no roots. So there are 0 roots. And here would be an example of that. There's a picture of a parabola that is never going to cross the x-axis. Okay, I could draw some other. So we could be going up on this side, or up on this side, or down on this side, or we could go across the x-axis, or the y-axis. We're still not crossing the x. So all of these, if I had the equations, would give me negative for the discriminant, and I know that means it does not cross the x, or it does not have any roots. All right, and if it has 1 root, like this one, the root is right here, the discriminant is going to be 0. So when you plug your numbers in for b squared minus 4ac, it's going to equal 0. If it equals 0, that means the parabola is sitting on the x-axis. The vertex is the only point that is on the x-axis. And it doesn't have to be going up. It could also be going down. Try to do that. There we go. Okay, but it's only got one point or one root if the discriminant is 0. Okay. All right, and then my next one, obviously, if the discriminant is positive. So if I plug in numbers for b, a, and c in it, I get a positive number of some kind. Fraction, decimal, integer, but it's got to be positive. That means there are 2 real roots. So, which means it's going to cross the x-axis twice, and probably, actually, yes, on the symmetrical points. Okay, so here, these would be the 2 real roots, here and here. Now, the discriminant doesn't tell you what the roots are, only how many answers you're going to have. That's all it tells you. It doesn't tell you what they are, just how many there are. Okay, here we go. Okay, it says state the value of the discriminant and tell how many real roots. So remember, if it gives us a positive number, I'm going to use the number symbol, that means we're going to have 2 real roots. And if it gives us a negative number, we're going to have 0 real roots, which means it does not cross the x-axis. And if it gives us a 0, when we put our a, b, and c in, that means there is 1 real root. Okay, so that's just a little notes up at the top so we can remember. So if you remember from when we were plugging numbers into that vertex formula, negative b over 2a, we were saying that this one is a, 4, b is negative 2, and c is 14. Now, if you remember during that lesson, if you watched the video, I said, you're probably wondering why I keep making you write c. Well, here it is. It's right here. Because you do use c, you just don't use it to find the vertex. You use it for the quadratic formula. So here we go. We're going to plug in. And we're just looking for the discriminant, so we're not doing the whole formula. We're only doing this part of the formula, b squared minus 4ac. So I'm going to take my negative 2 and put it in here for b. Negative 2 squared minus 4 times 14. And I'm plugging this into my calculator. So using my calculator, negative 2 squared minus 4 times 4 times 14 gives me negative 220. That's the discriminant, negative 220. Now, that doesn't mean that the parabola crosses at negative 220. It just means that the discriminant is negative. That's really all I care about. I don't care about the number, only that it's negative. And since it's negative, that means that there are no real roots, or 0 real roots. It looks like or, doesn't it? It's not. It says 0 real roots. All right, number 2, same thing, using the same formula. So here, notice I'm not set equal to 0, and I need to be. So I'm going to move everything over where x squared is positive, so I'm adding 144. This kind of looks like a perfect square. So x squared plus 24x plus 12 equals 0. So here, I'm going to change colors. A is 1, B is 24, and C is 144. And I wrote 12 over here. In my brain, I'm factoring it, sorry. Okay, 144. There we go. All right, so let's plug it into the discriminant. Remember that the discriminant is b squared minus 4ac. So 24 squared minus 4 times 1 times 144. Let's see what that gives us when we plug it into our calculator. 24 squared minus 4 times 1 times 144. That gives me 0, which means that there is 1 real root. Okay, it means it's a perfect square as well, and it means that the vertex is sitting on the x-axis. Remember, the vertex is the only point that's not symmetrical. All right, same thing here. It's supposed to be sitting equal to 0, and it is not. It is not in standard form this way, so we need to subtract 12 on both sides. So this is 3x squared plus 10x minus 12 equals 0. Now it's in standard form. Now I'm ready to write down my a, b, and c. So my A here is 3, B is 10, and C is negative 12. So we're plugging into B squared minus 4AC. So let's see, B is 10. So 10 squared minus 4 times 3 times negative 12. Let's type this in. 10 squared minus 4 times 3 times negative 12. 244. And again, you don't really care what the number is, only that it is a positive number. Okay, it's a positive 244. And because it's positive, it means that there's 2 real roots. Okay, so again, that's called the discriminant. When you take the A, B, and C and you plug it in to B squared minus 4AC, which is only a partial part of that quadratic formula. Okay, so there's some of those on your homework today. All right, so when we use the quadratic formula to find the solutions, we're going to put the equation in standard form. That's step 1. Step 2 is we're going to write down what A, B, and C are. And then we're going to use the gigantic formula, quadratic formula, and we're going to plug those values in and then use our math and PEMDAS skills to get there. We're also going to use our calculator. Okay, and obviously I'm going to check to see if it factors first, just so I kind of know if I was really taking the test or I was taking the SAT or something like that, which you guys will have to take. I would try to factor it before I did anything else, because factoring is faster and easier than using the quadratic formula. So I'm going to look to see if it factors just so I kind of know, but I'm still going to use the quadratic formula. But if it were the test and it factored, I'd stick with factoring. All right, so I'm looking here for factors of negative 35 that give me negative 2. So I'm thinking about 7 and 5 where the 7's negative. That works for me. So this one would factor. Okay, but I'm not going to factor. I'm going to use quadratic formula just to show you. So in this equation right here, A, there's no A, but there is an A. It's a 1. B is negative 2, and C is negative 35. Okay, then we're going to write our formula down. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, now let's plug. So X equals negative B. Well, B is negative 2, so that's negative 2 plus or minus B squared. That's negative 2 squared minus 4 times 1 times negative 35 over 2 times 1. So all I've done is taking the ABC values and plug them into the formula where they appropriately go. The letters and the numbers match up, or at least they should. Okay, so my next step is going to be to simplify this baby. All right, so we've got X equals, well, 2 negatives make a positive, so 2 plus or minus. Okay, then I'm going to stick this whole thing under here, the discriminant, underneath the radical sign. So here I go. Parenthesis, negative 2 parentheses squared, minus 4 times 1 times negative 35. That gives me 144, which makes me kind of happy. Because that's a perfect square. And then over 2 times 1 is 2. Okay, so now I'm ready to take the square root right here, especially since 144 is perfect. That makes me really happy. So that's X equals 2 plus or minus 12 over 2. And this is where I split it into 2. Okay, I knew that it was going to have 2 solutions because this came out as a positive number, positive 144. If the discriminant is positive, I have 2 real roots. I also knew it because it was going to factor up here. Okay, I knew it was going to come out not a decimal because it factors. Okay, so here I split it into 2. So X equals 12 plus 2 over 2. Okay, or 2 minus 12 over 2. So 2 plus 12 is 14 over 2. So this root is 7. And 2 minus 12 is negative 10 over 2, which is negative 5. So these are my 2 real roots, 7 and negative 5. Okay, and again, because I got whole numbers when I used the quadratic formula, I know it would have factored. Even if I wouldn't have checked it at the beginning, I know, oh man, I could have factored that because they came out integers. Okay, the quadratic formula is really for when you can't factor it. Like it's not a factorable trinomial and you end up with a decimal nightmare. Okay, that's really what the quadratic formula is for. Okay? All right, let's try another one. All right, number 5, it says solve your answer to the nearest hundredth if necessary. Okay, so obviously this one's not going to factor because it's telling me that I got to round my answer. And if it was going to factor, they would be integer answers, and you don't round integers. All right, so not in standard form. That was step 1. So I'm going to move the 4 over so that it is in standard form. Minus 4 on both sides. So 15x squared minus 8x minus 4 equals 0. And if I wanted to spend some time looking for factors of negative 60, they gave me negative 8, I could, but I'm pretty sure it doesn't factor. 6 and 10, 15 and 4, 20 and 3. I'm thinking no on the factor, and especially since the directions say round to the nearest hundredths. All right, so here we go. Got our in standard form our equation. So A is 15, B is negative 8, and C is negative 4. And my formula, negative B plus or minus the square root of B squared minus 4AC over 2A. All right, so let's plug. So here we go. X equals negative 8 plus or minus negative 8 squared minus 4 times 15 times negative 4. Ooh, I squeezed that in there. Over 2 times 15. Okay, so my B went in for B twice, A went in, C went in. I think we're in good shape. Okay, so now I go to the calculator, and I'm going to work on the discriminant first. So once I get this discriminant, I'm going to know kind of where I'm at, like root-wise. Do I have 2? Do I have 1? Do I have none? Okay, and if I have a negative here, it's going to be no solution. So let's see what happens. All right, so negative 8 squared minus 4 times 15 times negative 4. That's 304. Oop, right with the highlighter. And these two negatives make a positive. So 8 plus or minus 304 over 30. Okay, now 304 is not perfect. So I know that I'm going to have a decimal answer. I know I'm going to have a decimal answer. And that's really what quadratic is for. When it comes out, quadratic formula is for, is what it comes out a decimal. Because if it came out an integer, I should have factored it. Like on the last one, that one should have been factored. I shouldn't have to go through the big formula if I can factor it. So here we go. So x equals 8 plus or minus. Now I need to take the square root of 304. And what I'm going to write down are 4 digits. So I'm going to write 17.435, and it's 59. So I 1, 2, 3, 4. I want to stop right here. But should I stop at a 5 or a 6? Well, the 9 would pull it up to a 6. So I'm going to a 6. Now, understand that once we round inside of a problem, that changes things a little bit. Okay, that changes right where we are. So if you're using something like on your computer to figure out and you're really close but you're a smidge off, it's probably because we rounded right there. But the further you go out in decimal places here, the closer you will be to the exact answer, or close to the exact answer. So we're going to go out 4 digits right there. And I rounded the 6 from a 5 because there was a 9 there. All right, so now I break it into 2 problems, so plus minus. So 8 plus 17.4356, all divided by 30. And the other is 8 minus 17.4356, all over 30. And I'm going to use my calculator, obviously. But here we go. 8 plus 17.4356 equals 25.4356. Then I hit divide by 30. And I get 0.847. Remember, the directions told me to round to the nearest hundredth. So here's where I do hundredths. So this is 0.85 for the first one. That's the first root. And then I use the calculator again. 8 minus 17.4356 equals, and then divide by 30. And there I get negative 0.314. So my answer is negative 0.31. So these are my two roots that I got. Okay? And again, what those mean, that if I were to graph the parabola, that's where they would cross the x-axis. That's what that means. That's what I'm looking for. Where does the parabola cross the x? Okay? Questions? Okay. If you have a question, I'm online. All right, let's go here. Okay, number 6. I think this might be the last one. I hope you're noticing that this is just a lot of plug and check. Okay, I do want to point out real quick that make sure on this part down here where you're doing the two of them that you hit equals before you hit divide by 30. So you have to, in your calculator, you can't type it all in at once because divide comes before add and PEMDAS, and you'll get them all wrong. Make sure you're doing the add part and then hit equals, get an answer, and then divide that by 30. And make sure you're not doing it all in one swoop because you'll get every single one of them wrong. Okay, let's try this one. So solve, round your answer to the nearest hundredth if necessary. So I kind of look at it. 3 times 11 is 33. And 33, factors of 33 that give me 5. Well, I can only think of 1 times 33 and 3 times 11. And neither of them have a sum or a difference of 5. So it's not factorable, so quadratic formula is what I'm stuck with. So here we go. And it's in standard form. It's set equal to 0. So A equals 3, B equals 5, and C equals 11. So negative B plus or minus the square root of B squared minus 4AC over 2 times 3. Oh, I'm just doing the generic formula there. 2 times A, and it equals X. All right, so here we go. Let's plug. So X equals negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 11 over 2 times 3. Okay, so the first part, negative 5 plus or minus is going to stay the same. And then I'm going to stick this part here, the discriminant, in the calculator and come up with a number. So 5 squared minus 4 times 3 times 11. That gives me negative 107. Okay, at that point, I'm like, whoa, it's a negative. You cannot take the square root of a negative. So therefore, I can't go any farther. If you put the square root of negative 107 into your calculator, it says domain error. So I can't get a number out of it, at least not yet. You'll be able to do it in Algebra 2, but you can't do it yet. Okay, so since I'm stuck here and I can't go any further, the answer to this is no solution. The answer to that is no solution. And doesn't it make sense since the discriminant is negative 107? Remember, if the discriminant was negative, there was 0 real roots or no solution, which means that the parabola does not cross the x-axis. Okay, so that's as far as I can go. I'm done. Actually, I'm kind of glad sometimes when I get negative there because I'm done. I don't have to go any further and figure out both roots. I'm just done. Okay, so this is no solution. Oh, this is the last one, number 7. Okay, so first of all, not in standard form. Second of all, notice it says the directions are different. It says solve and leave your answer in radical form. Okay, there's no decimals here. Okay, so this is why we did 9.1 where we did, right here. Okay, so let's give this a try. All right, so first of all, I'm going to move the negative 40 over, negative 40s, because it's supposed to be set equal to 0, and currently it is not. So 2s squared minus 40s plus 100 equal 0. So I'm kind of thinking that it's going to factor, but not really a factoring unit. Let's go ahead and do this with the quadratic formula. So here A is 2, B is negative 40, and C is 100. And it might not factor. I didn't look super close. All right, so now we need the quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC over 2A. Okay, so let's plug. X equals negative 40 plus or minus the square root of negative 40 squared minus 4 times 2 times 100 over 2 times 2. Okay, so negative 40 is 40. And now let's figure out what the discriminant is. Use your calculator. 40 squared, or actually negative 40 squared, minus 4 times 2 times 100. That gives me 800 over 6, actually over 4. So 800 is not a perfect square. 900 is, but 800 is not. So in fact, I can prove it. If I put it in my calculator, the square root of 800, I get a decimal. And had it said, the direction said, round to the nearest hundredth, at that point, I would have gone with 28.2843 for that part. But because the directions specifically say answer in radical form, that means that I have to simplify this radical 800 like I would in section 9.1. So I'm going to go about it differently. So x equals 40 plus or minus. Now I got to break this 800 into a perfect and a non-perfect. So I'm thinking about 100 times 8. But then if you notice, 8 is 4 times 2. So these two are both perfect. So that means 100 times 4, 400 is what I'm going to use. 400 times 2 is going to be the two factors that I use, because 400 is 20 times 20. So if I break it into that, then 400 is perfect and 2 is not. And then on the bottom I still have the 4. So if I go ahead and take the square root now, 40 plus or minus, the square root of 400 is 20, radical 2 over 4. Okay, now the only thing left to do is to look right here and see if I can simplify those. If there is a number that will go into all three, I must simplify. So I'm thinking 4 goes into all of them. So 4 will go into 4. Whoops, I didn't mean to erase that. Let me undo that. Let's get a different color. 4 will go into 4 once. 4 into 40 is 10, and 4 into 20 is 2. So on the bottom I have a 1. I don't need it anymore. So my final answer, x equals 10 plus or minus 2 radical 2. That's my answer. Now I could put it over 1, but I don't need to. I don't need to. It's not necessary. It's not wrong, but it's not necessary to do that. That's my final answer in radical form. All right, you give this a try and see if you can try this. See if you can get this right. Go ahead and try to leave it in radical form like we did here. Actually, if you want to try it as a decimal, you can. And if you want to try it in radical form, you can. I will tell you on your homework, they don't ask for radical form. You may see it radical form on the SAT or ISTEP or something like that. I'm only showing it to you because you might see it later. But the decimal is what the book is asking for. Go out to the hundredths place, and when you take the square root, take 4 digits. I'll do it both ways. You can do it the way that you'd like. Go ahead and pause and try it, please. Okay, so it's already in standard form. It does not factor because the only factors of 7 are 7 and 1. So I know my answers are going to be decimals. 7 and 1 add up to 8 and subtract to 6. That does not equal 4 in any way, shape, or form. So I'm stuck with it. So A is 1, B is negative 4, and C is negative 7. So plugging it into the formula, negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 7 over 2 times 1. So that's just 4 plus or minus. Now I'm going to use my calculator. Negative 4 squared minus 4 times 1 times negative 7. That gives me 44 over 2. Okay, so if I do it as a decimal, I'll do that first since that's how your book is. So I'm going to take the square root of 44, and I'm going out 4 digits. So x equals 4 plus or minus 6.6332 over 2. And this is where it breaks into 2. So 4 plus 6.6332 over 2, and 4 minus 6.633 over 2 over 2. Okay, remember, you have to hit equals here before you can hit divide by 2. So here we go. 4 plus 6.6332 equals divided by 2. Directions are hundredths place. So 5.316 makes that one 5.32. That's my first root. And then if I do it again, this time with a minus sign, 4 minus 6.6332 divided by 2 is negative 1.3166. So that's negative 1.32. So these are my two answers that I would put in the book, because the book is asking for decimals when it doesn't come out nicely. Now, if I go from here, and this time I do it in radical form rather than in decimal form. I'm going to change color so you can tell the difference. Yeah. Okay, so I've got 4 plus or minus, and I'm going to change that 44 to 4 times 11, where 4 is perfect and 11 is not. So that's 4 plus or minus 2, radical 11 over 2. And then I have to look at these three and see if they share a common factor. And they do. They all share a factor of 2. So I cross out the 2 and make it a 1. I cross out the 4 and make it a 2. And I cross out the 2 and make it a 1. So my final answer is 2 plus or minus 1 radical 11. Okay, and this 1 right here is optional. If I don't put the 1 there, that's okay. I know it's there, but I don't need it. But if I do write it there, that's also okay. That's allowed. Okay, so we did one to, hopefully you tried either the decimal or the radical, and you were able to get that. So if you did get it, give yourself a pat on the back. All right, so your assignment is in Big Ideas. You're doing 3 to 7 odds and 9 to 23 all. Okay, give them a try, see what you come up with. I'm available for conferencing every day, 12 to 1. So I'm not seeing very many of you, so that's telling me that you're understanding what you're doing. So I hope all is well, and take care.